Have you ever wondered how AI understands the words you type, even if they're messy or unique? It all starts with a process called tokenization, where your sentences are split into smaller bits called tokens. These tokens are like puzzle pieces, helping AI see the bigger picture of your message. Instead of reading whole sentences, AI looks at each token individually, checking how they connect and what they mean together. Tokenization works by breaking down text into chunks. Sometimes these are whole words, sometimes just parts, or even punctuation. For example, the word unbelievable might become undash, believe, able, three separate tokens. This split lets AI handle complex language, even when we use slang, typos, or foreign words. First, when you type a sentence, AI scans it line by line, identifying the smallest meaningful units. Next, an algorithm divides the text using rules derived from huge datasets, segmenting it for easier processing. These rules are built from millions of examples, so AI can quickly match patterns, even if your phrase isn't traditional. Then, AI forms a sequence by lining up tokens in order, each tagged with a number, so it knows their exact positions. This mapping reveals relationships between words, helping AI understand context, irony, or emotion based on order and proximity. Behind the scenes, things get technical. Each token is assigned a unique code, turning language into numbers a computer can process. AI models rely on token limits. Too many tokens might cut off your message, limiting how much the system can analyze at once. Some AI models use byte pair encoding, grouping common letter pairs into tokens to reduce memory use. Others, like those for different languages, might split text by characters or grammar rules, customizing their approach for each language. The magic is in the model's memory. It recalls patterns from past training, weighing how tokens interact to predict meaning. For example, the phrase ice cream is tokenized differently than ice and cream separately, recognizing that it's a single concept. This matters in everyday tasks. When you search online, write emails, or chat with AI, tokenization helps deliver accurate responses by translating your words into data. AI also uses tokens to power spell checkers, translators, and voice assistants, helping them catch errors, translate ideas, or recognize names. Errors can occur if tokenization splits words strangely. For instance, in medical texts, breaking high blood pressure into wrong tokens could change its meaning. Sometimes, rare names or slang confuse the algorithm, resulting in odd outputs or misunderstood intent. Models face limitations. They might miss nuances or context, especially if you use emojis, code, or mixed languages in one message. Risks include data loss if a system's token cap chops off vital info, or bias if the algorithm is trained on limited language samples. But advances are coming. Newer models aim to better handle mixed language, rare words, or even images alongside text tokens. As AI evolves, tokenization technology will sharpen, unlocking more accurate understanding and broader communication tools. Imagine AI helping doctors, teachers, or travelers by rapidly converting spoken words into precise tokens for instant insights. This could bridge global gaps, letting people converse in real time across languages with seamless digital support. Ultimately, tokenization is the quiet engine beneath our digital world, converting messy human text into clean, program-ready pieces every second. It's not just about breaking words apart. It's the foundation for AI comprehension, powering better interactions and deeper insights. From chatbots to search engines, tokenization shapes how machines serve billions, making conversations smoother and smarter. Whether you're texting, searching, or translating, it's tokenization that makes AI responsive, reliable, and ready to help.